Hi everyone, welcome to my second math video, and today let's talk about geometry. Let's see the special angles when we've got two parallel lines. So we can see in this case that line AB and line CD are parallel. This is the parallel symbol. What we have to do first is we need to create another line that intersects the two parallel lines. And now we've got 8 angles. I'm just going to name them. Let's look at the first type, vertically opposite. Vertically opposite angles are two pairs of equal angles formed when two straight lines crosses. And it's pretty obvious they're opposite angles. So we can see in this case, for example, angle 1 and angle 3 are vertically opposite angles, or angle 2 and angle 4, and also we've got angle 5 and angle 7 and angle 6 and angle 8. Next, alternating angles. Alternating angles are a pair of angles on opposite sides of the transversal between the other two lines. When I look for alternating angles, I look for Z or the opposite of this. What do I mean? So if we look at this graph again, we can see that there is a Z here, and we take the turning points of the two Z's, and that will be angle 3 and angle 5. And angle 3 and angle 5, they are alternating angles. And also, you need to look at the opposite of Z, which is this kind of weird opposite Z. And in this case, we see that there is an opposite Z here. And as usual, we take the two turning points. In this case, it's angle 4. It's angle 4 and angle 6. And angle 4 and angle 6 are alternating angles as well. Okay, so just look for the Z and look for the turning points. Next, corresponding angles. There are angles that are in corresponding positions at each intersection. Typically, you've got angles like this, for example, and those are the responding angles. And also, these will be the corresponding angles as well. Actually, it's like you just drag the angle. It just changes position, but the other things, it doesn't change at all. And they share one side of the intersecting line. Next, the cointerior angles. They are a pair of angles on the same side of the transversal and between the other two lines. So if you zoom in, it will look like this. So those two angles are cointerior angles. They are in between the two parallel lines. And it's important to know that they add up to 180 degrees. The reason I write those three and this one in different color is because the relationships are different. Those three, the vertically opposite angles, alternating angles, and corresponding angles, the pair of angles, they're the same. So the value is the same. So for example, angle 4 equals angle 6, angle 1 equals angle 3, and all that. But cointerior angles, it's not the same. The angles add up to 180. So like it's easy to get confused, but pay extra attention on this. Next, let's talk about triangles. I'm going to go over 5 things with you about triangles. First, equal side equals equal angle. There are way too many equals in the sentence, but it's a very useful phrase. We've got a triangle, and we know that AB equals AC, so it's an isosceles triangle. And now we want to show the equal angles. So first, let's look at the lines AB. AB corresponds to angle C, and AC corresponds to angle B. So in triangle, it's always like cross-corresponding, because AB equals AC, and AB corresponds to angle C, and AC corresponds to angle B. So it is true to say that angle C equals angle B. So that's what I mean by equal side equals equal angle. You can also do it backwards. So if I know that angle C equals angle B, I know that angle B will correspond to angle A. It's just like a reverse corresponding, and angle C corresponds to line AB. And I can do it backwards to prove that AB equals AC. Continuing, let's talk about the sum of interior angles. First, let's talk about triangles. So here we've got a triangle, and I've named interior angles angle 1, angle 2, and angle 3. And the formula would be angle 1 plus angle 2 plus angle 3 equals to 180. But we've also got a general rule here that applies to all polygons. No matter if it's like a triangle or a rectangle or a pentagon, anything. As long as it's a polygon, it applies to this. So the interior angles would be equal to n minus 2 multiply 180 degrees, which n would mean sides of polygons. So how many sides the polygon has. If you remember this general rule, you don't have to remember this anymore. Why? Because you can just use this general rule in the triangle. So we've got this rule n minus 2 multiply 180. In this case, we know that triangle has 3 sides, so n would be equal to 3. So it's going to be 3 minus 2 multiply 180, which is just 1 multiply 180, which is 180 degrees. And that would be the same to this formula, but, well, there's one less formula to remember. After talking about the interior angles, let's talk about the exterior angles. I have marked all the exterior angles with angle 1, angle 2, angle 3 as well. And the formula is angle 1 plus angle 2 plus angle 3 is 360. Yes, we've also got a general rule, but the general rule is exterior angles of polygons equal to 360 as well. So when it comes to the sum of exterior angles, just remember 360 and you're good to go. And you don't need to know it, but I find that this formula has made things a lot easier. So this is a formula for the exterior angle in triangle. What do I mean? For example, in this case, I've got an exterior angle 1 and I've got 2 interior angles 2 and 3. In this case, angle 1 would be equal to angle 2 plus angle 3. If I say it in words, it would be an exterior angle of a triangle is equal to the sum of the opposite interior angles. It applies to all exterior angles in a triangle, but you just have to change the interior angles accordingly. And last topic for this video, we are going to go into concurrent triangles. It might sound really difficult and messy at first, but let's try it if you can get over it today. We're going to talk about 4 ways to prove concurrent triangles. First, it's SSS, which means side, side, side. So if you know the 3 sides of 2 triangles are the same accordingly, then they are concurrent. And second, let's talk about SAS, which is side, angle, side. And you can see from the word that the angle is in between of the sides. So it means that it's always 2 sides and the included angle. 2 sides and the included angle. It needs to be included angle. If you've got an angle, let's say I know those 2 sides are the same and I've got an angle, let's say here. It won't work. It has to be included angle. Next, AAS, angle, angle, side. So 2 triangles are concurrent if 2 angles and a side of one triangle are equal to the 2 angles and the matching side of the other. In this case, it doesn't really matter where the side is positioned. So let's say I've got those 2 angles are the same. This S, it doesn't matter if it's the included side or the adjacent side, as long as there's a side, it's okay. And last one, it might be a bit different, you see, because it's not angle or side anymore, it's RHS. It actually refers to a special type of triangles, the right angle triangle. And The definition is two right-angled triangles are congruent if the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle. So actually it means the R it's the right-angled. So it has to be two right-angled triangle. The H means hypotenuse. So the hypotenuse needs to be the same in order for this to work properly. And the S, well, it's just a side. So you can see from the graph, the right angle triangle, the hypotenuse is the same, and another side is the same. I hope my explanation clears it up a bit for you. And if you have any questions or any suggestions, just leave it in the comment. I look forward to our next video. And yeah, I hope you've learned something, and bye.